to make sure, to ensure that your sample is random. Okay. Random is not haphazard. Random is not careless. Random is the carefully designed way to make sure that the odds are equal. You're not biasing one group against another. The application of specific statistical test. One very common mistake, even in published journals. Okay, if you pick up many papers, even in high-impact journals, very often you would notice that the application of students' t-test in the setting of multiple groups, or the application of students' t-test when the sample distribution is not normal. This perhaps is one of the biggest, one of the most frequently committed mistakes in statistics. The failure to correct for false discovery in the setting of multiple testing is another frequent mistake. And the presentation of results. Okay. A lot of times you can, say one way to present the data is wrong, but very often there are preferred methodology or preferred type of presentation of the data. But sometimes it could be a personal preference. Okay, I would close this talk with this slide. I would emphasize that scientists are seekers of the truth. And statistics is a fundamental part of the scientific method. You need statistics to help you to separate fallacies from the truth. If you don't know statistics, you don't know science. Okay? Vincit omnia veritas. The truth conquers all things. That's all, folks. Thank you. Questions?
Could you talk about the calculation of p-value and what value of p-value is acceptable? Because I see that sometimes the p-value is very low, sometimes the p-value is very high. And if the p-value is very high, could be conclusion that the experiment is not believable.
The p-value represents the alpha value, is probability. We accept the alternative hypothesis if the p-value is less than 0.05. Now, if the paper say p less than 0.001, okay, that means we are very sure. There's a less than 1 in 1,000 chance that I was wrong. Okay, so the lower the p-value is, the more sure you are about the conclusion. If your p-value is higher than 0.05, that means you cannot reject the null hypothesis. But indeed, is there no difference? Truly no difference? You don't know. You have to look at the beta value. Okay, so you have to calculate the power of your study. If your power of your study is greater than 80%, that means in general we accept a beta value of 20%, meaning that there's less than 20% chance that I would be rejecting that I would be accepting the null hypothesis incorrectly. So you have to calculate both the alpha and the beta. So you want the beta to be less than 20. You want your alpha to be less than 0.05. Okay. If you have your alpha less than 0.05, then you accept the alternative hypothesis, and the lower your alpha is, the more stronger your conclusion is. Did I answer your question? How to calculate the p-value? That I do not know. Different tests calculate the p-values in different ways. The bottom line is that the p-value is the probability, and the probability is based on different tests use different statistics, the actual parameters for comparison. Like I'm not a mathematician, but when I take the statistics course, in the calculation of the p-value for the t-test, there's some certain formula that I got already. So you just plug in the numbers into the formula and do the calculation. But that's specific for the t-test. For a different test, it's a different formula, different ways. So. Okay. The metformin is a drug used in type 2 diabetes. The way it works is by improving the insulin resistance in the whole body. Okay. When the insulin resistance is improved, the body, the beta cells does not need to secrete or over-secrete insulin to compensate, to keep the blood sugar normal. So therefore, by improving insulin resistance, less insulin is needed. So therefore, the circulating serum level of insulin of the whole animal would go down.
Hello. Hello. Bây giờ em không có ở phòng bởi vì là em đưa rồi. Đấy, rồi anh chị bảo anh chờ lát tí người lại nhé.
You have to take into consideration of the decay of the radioactive nuclide. So therefore, you have to have a control group that is performed at the same time, and you do the measurements at the same time, so that decay is not an issue.
So the last question I would like to ask you, so you mentioned about the control, like now specific for your experiment, so what difference between control and positive control?
Control and positive control. Okay. The positive control is to make sure that the methodology of your experiment is working. Okay. The positive control, it is not part of the control for your experiment. The control for your experiment is to control for the variable that you want to change. For example, if you want to evaluate the effect of drug A. Okay, so you incubate with one group of samples with drug A. Okay, that's your experimental group, and your control group would be incubated with control culture media without the drug. Okay, that's your control or the variable about the drug. Okay. But your outcome variable, the test that you want to test, you measure. For example, if you want to do Ki-67 measure, okay, how do you know that your antibody to stain the Ki-67 is working? Okay, so if you end up with no staining of the Ki-67 in your control cells and in your cells stained with drug A, what is your conclusion? That drug A does not make a difference? Or is there something wrong with your technique that you're not staining the Ki-67? So what you mean by positive control is that you have a different kind of cells that you know for sure would have positive staining with the Ki-67. And you demonstrate that using the same methodology, the same technique. I can stain Ki-67 in cells using this method. Okay, and with this method, I don't see any difference in staining between drug A and the placebo control. So that is what we mean by positive control. The positive control or negative control is for the methodology, the methods that you want to analyze, the outcome result. Okay. Whereas the control for the variable that you're testing is different.
When I compare the proportion of my study to